Hello Year 12, welcome to the notes on partial fractions. Okay, so let's start off with something that we should have been able to do in GCSE, adding and subtracting algebraic fractions. Now, all you need to do whenever you're dealing with fractions is find a common denominator. So in this case, that is going to be found by multiplying our x plus 1 and our x plus 2 together. We need to do that to the top and the bottom of the fraction, and the one on the left we're obviously going to times by x plus 1, the one on the right we're going to times by x plus 2. After that, it's just a case of collecting your terms together, of expanding them, and really make sure that this is a minus here. And then collect your terms. 3x minus 2x gives you the x, 3 minus 4 gives you the minus 1. On the second example, we want to do the same thing. Given the common denominator, collect our terms together, expand our brackets, and then simplify. One thing I have not done is I have not expanded the bottom terms at any point there, and that's kind of key to algebraic fractions in general. And what that points out is that if we have a fraction where we can factorize the denominator into two linear factors, then we can split it into two separate fractions with those linear factors. So partial fractions is about running that process in reverse, about taking a fraction which has been put together and by splitting it apart into its linear components. Now if we look at this, we know because we've got x plus 2 and x plus 1 as our denominator that that's going to be the two denominators of what we end up with, and all we're going to do is we're going to directly equate those two expressions like that. Now we've then got a couple of options about what we want to do, but to start off with, we do need to multiply up. We're going to multiply every single thing there by x plus 2, x plus 1, and then that'll allow us to do some simplifying. We can cancel out the x plus 2 and the x plus 1 here, we can cancel out the x plus 2's here, we can cancel out the x plus 1 here, and we just end up with a nice, straightforward, linear expression. From this point, there are two possible methods to try and find out what a and b are, and one isn't really necessarily better than the other. It kind of depends on the numbers you've got. The first option, the one people would most likely go with, is to try and make zeros happen. So we're going to use the substitution method. We're going to sub in minus 1 and we're going to sub in minus 2, because minus 1 will make this fraction disappear and minus 2 will make this one disappear. If we sub in minus 1, then we'll get this expression, which we can simplify to minus 2 is equal to b, and so b is just minus 2. If we sub in minus 2, we'll end up with minus 3 is equal to minus a, and so a is equal to 3. Very straightforward, zeros are plenty, good times. The other option we can do here is we can use what's called a coefficient method. Now this is a bit more complicated. It's quite similar to stuff you will have used in binomial methods, but there are some partial fractions where this is necessary, and we'll come to those later, but I want to show you how it works on relatively easy ones. So I'm going to start by expanding the brackets there to ax plus a and bx plus 2b. I'm then going to equate some things. So everything that has an x on the left hand side is going to be the same as everything that has an x on the right hand side. X is equal to ax plus bx. Similarly, anything that has a number on the left hand side, so we've got minus 1 here, we've got a here, we've got 2b here, I can combine them together into an expression involving just numbers. If I then ignore the fact this has got x in, I can just say that, well, 1x is equal to ax plus bx, so 1 is equal to a plus b. And that gives you your two separate simultaneous equations. We can solve them through any number of methods. You should get the same values of b and a. Now, putting that all together, what we want to do is actually answer the question. So we would say, in general, that our expression is equal to 3 over x plus 2, because that's what we found a is, minus 2 over x plus 1. You could say plus minus 2 over x plus 1, I suppose, but that would be bizarre. For the next couple of slides, I'd like you to pause the video, try the question, and then see if you get the same answer I've got. These should be written down essentially as examples. So our first one here, we are told what form it needs to be in, so let's multiply up. So we've got a linear equation. And then there are two obvious options. We could use substitution. If we did that, we should get that a is a half, or b is 3 over 2. Or we could use comparing coefficients. We'll end up with two simultaneous equations, and those will give us the exact same answers. We could write our answer as a half over x minus 1 plus 3 over 2 over 3x minus 5, but it's actually probably a little bit nicer to take that 2 down to the denominator and have our final answer look something like this. Once again, have a go first. Now, the thing that's different on this particular question is it doesn't tell you what the answer needs to look like, but it's fairly straightforward to work out that we just split the linear factors up. We then multiply up to get the same thing we've normally got, and here's a substitution method to find out that b is 1 and a is minus 1. We could write our answer as it looks over here, but it would probably be a little bit nicer to put the minus afterwards, so we've got no minuses inside our fractions. So here we have three factors, which means we need to split up our expression into three different fractions. The actual multiplication out of this looks absolutely horrendous, but you are just cancelling things out at the end of the day. So everything on this left-hand side will cancel. Some things will cancel here, some things will cancel here, some things will cancel here, and you end up with a slightly nicer looking expression. This is definitely a situation where I would use substitution, because expanding and putting together the right-hand side looks like it'll be fiddly to me. We can sub in 1 to try and find the value of A. We can sub in minus 2 to try and find the value of C, and we can sub in minus 3 to try and find the value of B. Put that all together and we should have this as our answer. Again, have a go first. So for this one, the trick is that we need to factorize the denominator. Fairly simple factorization, x plus 3x minus 1, and that means we know how it's going to split up. We can then do the same sort of thing. We do end up with some fairly gnarly values for a and b, so just make sure that you're putting them in the correct place and you're simplifying them like we did before. Okay, once again, have a go. Now, the trick with this one is that it's a little bit of an awkward factorization. You've got to recognize that you can split up x cubed minus x into lots of x squared minus 1, and then you can split that up further using the difference of two squares. After that, it's a standard partial fractions question. We set up our equation. Substituting 0 first is probably best because it will get rid of all of the ones with just x in them. That'll give us a is 3. If I sub in 1, I'll get that c is 5. If I sub in minus 1, I'll get that b is minus 2. And we'll end up with this as our final answer. So that's that for the first half of partial fractions. I'd like you to try exercise 1D.